Hi guys, here's an example of a problem, an application problem from 7.8. This is number 34 on page 605. So why don't you take a minute to read it by pausing this video, reading through it, and then I'm going to start. Okay, so A says approximately when will the next high tide occur? That one is probably the easiest part of this problem because we have high tide occurred at 8:06 a.m. Low tide occurred at 2:48 p.m. and it says high tides, the length of time between consecutive tides is 12 hours 25 minutes. So we basically need to look at the last high tide, which was at 8:06 a.m. add 12 hours and 25 minutes to that. So I'm just going to do that down here. So 8:06 plus 12 minutes, 12 hours, 25 minutes gives us 8 o'clock, 8:31 p.m. So that one's a pretty easy part. B is asking probably what you guys are really looking for in an example. It says find a sinusoidal function of that form. So what we need to do next is find our values for A, B, omega, and phi. So let's look at those. So according to the example that I gave you, that last example on 7.8, A is our high tide would be 8.13 feet, so it's our max value. The low tide was 1.95 feet, so that's what we're looking for when we're looking for amplitude here. So this is going to be max, which is 8.13, minus min, which is 1.95. Divide that by 2, and you get 3.09. So that's our A value. Okay. Next up, we found in that example from 7.8 notes, we found B. The only difference between A and B, we're going to be adding instead of subtracting. So it's 8.13 plus 1.95 divided by 2. That's going to give us 5.04. So those are probably the two easiest things when you're looking at these sinusoidal equations. Next, let's find omega. Omega is 2 pi over the period. Period is given. Sorry, I'm in a school. There's some noise happening here at my son's basketball practice. Okay, period is given for us. Actually, we used it in A. It was 12 hours and 25 minutes. Okay, so I'm going to write that on the side here. Period, which is T, is 12 hours, 25 minutes. So I debated whether or not to give you guys this as, like, leave it as a fraction. For now, let's leave it as a fraction, and then later on when we figure out our phase shift, I'm going to change it to a decimal. It's pretty much what the answer in the book said, so I'm going to do that. So the period is going to be 12 hours and 25/60th of the remaining hour, which is 745 minutes divided by 60. So that's how many hours the period is. Okay, and then later we're going to use our decimal approximation, not right now, but later on we're going to use about 12.4 hours. Okay, so in order to find omega, we're going to do 2 pi divided by t, and I think this is the part a lot of you had questions on in class. 2 pi divided by t, if we use this fraction as t, 745 divided by 60, we're going to divide by that, which means we're going to multiply by the reciprocal. So this is 2 pi times 60 over 745. And then this would be 2 times 60 is 120 pi, leave our pi in there, over 745. That reduces to 24 pi, because both 120 and 745 are divisible by 5. So this is 24. 120 divided by 5 is 24. 745 divided by 5 is 149. So that is our omega. Okay. Next up, and I'm just, again, following the same plan as our guided notes, let's figure out phi. Okay, so we have to divide our period, which now I'm going to use my decimal approximation, just because your book did. If you, I mean, you can stick with fractions, but you probably don't want to. So we're gonna say it's about 12.4. We're gonna divide that into 4 equal subintervals. Because what we know is we know where the high tide is, and that's going to be our local maximum. So once we divide it into our 4 equal subintervals, we're going to figure out where that local max is going to be, and we'll do a phase shift so we can get it to that high tide point. Okay, so I have, if you divide 12.4 into 4 equal subintervals, it's going to be, the first one's going to be 0 to 3.1, 3.1 to 6.2, 6.2 to 9.3, and then 9.3 to 12.4. Okay, so if you think of the sine wave has a max right here. This would be like our, like in our parent function of sine, this would be at like pi over 2 comma 1. Okay, so this is the local max of the sine wave, which in the problem, let's go back up here to the problem, it says high tide occurred at 8.1 hours. So we need to change this 3.1 into, I'm gonna put was 8.1 hours. So we need to do our shift. So our shift, we wanna take that 3.1 and move it to 8.1. So this is going to be a phase shift to the right. Sorry, I'm holding my, I have this on a tripod, but I'm holding it because it's not long enough. So it's a right phase shift of 5. Okay, so remember phase shift is phi over omega. So let's do that. 5 equals phi over omega. Okay, we know what omega is, but the good thing is, we can do this. So we're solving for, again, we're still working on part B. Part B says, and I'm gonna write this down as I show you, y equals a sine omega x minus phi plus b. But remember, what we can do here is take that omega out, because look what we have. We have our omega value, it's 24 pi over 149, and that's done. And then what we have for this phi is phi over omega is 5. So if we factor an omega out here, it's just gonna make it easier for us to write. So I'm gonna take out that omega, I'm left with an x minus phi over omega. Okay. So then this is gonna be A, we're just gonna plug in our values now. A, we found earlier, it's 3.09. Okay, omega is 24 pi over 149. And then our phi over omega is 5. So that one's easy to plug in right there. And then our B value that we found from before is 5.04. And I think your book is, in your book, like the answer was, it was acceptable to not distribute this 24 pi over 149. If this were a test or quiz, I would let you know what I wanted, okay? But, so you could distribute this if you wanted. It would be 24 pi over 149 times x minus 120 pi, 24 times 5 is 120. 120 pi over 149. That would be fine. In fact, let me just write that. So if you're asked to simplify, this is what you should do. So it'd be 120 pi over 149. Okay, and then plus 5.04. And that would probably be the best answer. But like I said, the answer in your book was this one with the double parentheses, which is fine apparently. It just depends on what you're asked. And then C, let's read C. It says, use the function found in part B to predict the height of the water at 6 p.m. So, oh, it's given the answer there, 5.95. So here's the, I guess, one little tricky part about C is 6 p.m. So we used, like 8:06 a.m. was 8:06. But we need to add, we're kind of got to do military time because it's the 6 p.m. is really the 18th hour, okay? So x, and not, x would not equal 6, x would equal 18. So the only thing you need to do is be really careful in your calculator when you're plugging this in. So you're going to type in your calculator 3.0, make sure you're in radian mode. And you guys check this because I did this earlier and this is what I got. So if you plug in 18 for x right there, you type in your calculator 3.09 sine 24 pi times 18 divided by 149 minus 120 pi divided by 149 under your parentheses plus 5.04. You should get 5.94. So it says predict the height of the water, and then the only other thing we need is a unit, which is feet. Okay, so that'll do it. Let me know if you have any questions about what this problem was. Again, this is in your book. I got it directly out of your book, page 605, number 34. Thanks, guys.